Okay, so proof of cosine rule. So it's similar enough to how we start off to the sine rule. So the proof of the cosine rule for a triangle with angles ABC and sides ABC, as shown, prove the cosine rule is given by a squared equals b squared plus c squared minus 2bc cos a. Okay, so you draw your diagram, so you draw your triangle, just like in the cosine rule. We drop a h down here. We'll name the intersection point here, though. We'll call that D. Our triangle will, like the last time, will be ABC. And we name our sides. Opposite A is side A, opposite C. So it's hard now because we got D down here, so we got to be careful that D isn't, we're not mistaking that for the length of the side. The length of this side is lowercase c. That's the name of that side. And opposite this side is B. Now what we pay attention to here is what we'll also include is the length from A to D here. We're going to call that X. So if the full length is from here to here is C, then the remaining length here is C minus X. Okay, so that's our diagram. Now let's just say, let's just comment on our diagram. So we'll say in triangle ABC, the length from C to D is perpendicular to AB. Actually, yeah, sorry, I shouldn't have those lengths there, because that means length. I'm talking about the line. Okay, it's perpendicular to AB. Right, so what else do we have inside this diagram? We have said that the length of C to D is, we're calling that H. Let's call that H, that's H. And then we're saying the length from A to D, we're calling that X. And then we are saying D to B, hence D to B is equal to C minus X. All right, I think we have everything defined there now. Yeah, perfect. All right, so let's start off with our left-hand triangle, triangle ADC. So in ADC here, we're just going to use Pythagoras' theorem. Obviously, B is my hypotenuse. So in triangle ADC, then the hypotenuse squared equals the sum of the other two sides squared. And just like in the sine rule, I'm going to get h on its own. So h squared equals b squared minus x squared. Okay. Then I'll focus on the other triangle. The other triangle is BCD. And we do the same thing again. This time A is the hypotenuse. A squared equals h squared plus c minus x to b squared. Okay. So yeah, and then we get h on its own here. So h squared equals a squared minus c minus x to b squared. All right. Okay, so now we've got two h's. We can equate the h's to each other. So this is h squared, this is h squared. So obviously the two expressions must be equal to themselves. So therefore, what have we got here? A squared minus c minus x to b squared equals b squared minus x squared. All right, let's square everything out. So a squared minus c squared minus 2cx plus x squared must be equal to b squared minus x squared. All right, we'll apply our minus. A squared equals, a squared minus c squared plus 2cx minus x squared. You can see now we're starting to get stuff that looks like the cosine formula. So we get a squared on its own, because that's what our cosine formula actually looks like. We have a squared on its own here. So bring everything else over to the right. So we get b squared plus c squared minus 2cx. And what happens to our x squareds here? When minus x squared comes over, it'll cancel with the minus x squared over here. All right, so we're nearly there. So we just have that minus 2cx at the end that we need to convert. What should we have at the end? It's almost perfect, but instead here we should have minus 2 BC cos A essentially. So I have a C in there, but I don't have a B and I don't have a cos A. So let's look at the cos A. We have angle A. Let's look at angle A here. Angle A is in this right angle triangle. So let's get the cos of the angle A. Cos is adjacent, which is x, over hypotenuse, which is b. So x is equal to b cos A. So I can swap out x for b cos A. All right. So you make sure you kind of note that down there. So a squared equals b squared plus c squared minus 2c, and then I've got b cos A. And then all we do is just arrange it perfectly. Plus c squared. So we just rearrange this because they're multiplying. Minus 2bc cos A. And then at the very, that'll do fine. And then you can say at the end, similarly, it can be shown that c squared equals b squared plus a squared minus 2ba cos c, and b squared equals c squared plus a squared minus 2ca cos of b. Perfect.